We still shouldn't be advancing past what we had before. So like none of that should make a difference, right? It does. Ooh, fuck. It's probably this. Yeah, probably that. Okay, that's better. Okay, now we can rid ourselves of that hell. Okay, so this read helper. Now, the thing is, this will only read one thing. I kind of need to construct an implicit... Like, should the top level be scoped? That's an interesting question. Or I wonder if module is a form that I want to have, because that implies I have to do module resolution, which I'm kind of at the moment just treating dots as part of an identifier. I don't know if that's a good idea or not. It certainly gels well with the compile down to C part, where I don't have to do module resolution. Though C, the dot does mean something. I kind of plan on fucking with all the names, though, when compiling down to C, like mangling them, essentially. Not in a sophisticated sort of way, just assigning them like random numbers, basically. Except for ones that you want to export. The ones that you want to export will be given the name at the lowest level of scope, probably. He says, probably. I don't think you can use a colon in an identifier in C, right? Like, it's part of a bit field. Void main, void, int xa equals 1. I don't think I have GCC Clang. Yeah, it doesn't like that. That's fine. That's fine. Okay, so we can pass one thing. Or we can read one thing, rather. Now the question is, what do we want to do with it? So this is... Do we have any nice, probably not, but do we have any nice like option piping kind of monad-y type stuff? Oh, we do have a compose. Oh, that's kind of nice. We have a compose. I guess, the question is, what are we going to do about this? Because the parser should go to an internal structure. Option.compose. And then how does this work? We just give it to two things. My eyes have glossed over where it is. Give it an A to B and a C to A option and a C to B option. It returns some fy if gx is some. Gx is some y, it then does some fy. Even if f... Oh, no. I think I want compose partial. A C to A option, an A to B option, a C to B option. Yeah, that's what I want, compose partial. Returns fy if gx is some y, returns none otherwise. It holds that compose partial equals map partial, whatever. Compose partial, and then I think I want like parser dot parse and this returns a function? It does. Reader dot expand, and then I want to apply that to compose partial, and then I want to apply that to source, I suppose. Yeah, because that gives me a T option where T is, yeah, just at this level, which works. Should I have numbers as well? I don't know. It doesn't matter right now. That's a later problem. So that's the reader, and then the parser will have a value parse, which will be, it'll take in a reader T and return a T option, I guess. And then parser.prettyprint parsed, I guess. And we also need, obviously, then a value prettyprint, which I guess just takes in a T and returns a string, I suppose. And our prettyprint function, which takes in a T and returns a string unimplemented. Brilliant, farmer. Genius. And then parser will take in a reader T and return a T option. None. Okay. Sure, we'll do expand later. Reader read. Okay, cool. Is that how that works? I think unit's the type. Yeah, I think I have to do, whoops. I think I have to do that. Yeah, cool. Alright, we spent a long ass fucking time reading that document that I'm not sure if I want to actually do this now. 1 hour, 40 minutes, 50 minutes. So what would we have to do? We'd essentially have to recognize the keywords that we want to recognize. Then what? Just pause them, I guess, because there are primitives. We don't really have a lot of syntax. Our primitives are handled through kind of special functions, I guess. So I guess data type ops, maybe. Claim lambda, alias, function, I guess. Bind. We might reserve these words as well, I'm not sure. Bind is this one, functions that one, equals that one, primitive or prim. I guess we're using prim. What did I have up here? Oh, these are the types themselves, but not the keywords. Yes, yes, that is true. Do I want them to be the same? Are they allowed to be the same? Probably. I have no idea though. Let's find out. We'll also do this. Some prod match equal. Is equal going to be the only primitive one? I think so. Do we have prim? We do not. Prim. Okay, is that allowed? Okay, it's allowed. Probably because you can scope them to parser. Alright, and then when parsing, what we want to do is we want to walk through the lists. Frankly, this shouldn't be lists. It should be a list of, or a vector of lists, because you can have a bunch of top level things next to each other. Should we hide that detail? That's a good question. Should we have forest instead of just list? Because what happens if you just have an atom by itself without a list at the top level? Like, is that allowed? Because I know you can do that in Scheme, for instance, and probably Common Lisp, I don't know. And the idea is that the last thing in the top level, if it is a value, the return of evaluating that, when you evaluate the file, or when you evaluate that top level context, it returns the value that was last in that file. Which kind of makes sense, I guess. I don't know. But I don't think this is a detail I want to expose. Oh, wait, isn't that just a list? No, not quite, not quite. They're semantically different. Because in a list, the first element of that list is treated, the list is treated as like a function application or a function call. And so the first element is like the name of the function that you then supply the rest of the list as arguments. But for a forest, they just exist independently. So yes, so for forest, yeah, I guess we want to do something similar. But more like that, I guess. I guess this is like read forest, because it should keep going.